All right, so you've got Python installed, you've opened Spider, you're gonna go ahead and open it up on your screen and it's gonna look something like this. What you're gonna see is you're gonna see some text in gray, you'll see they have hashtags in front of them, that means it's a comment, the computer won't read it, and then you'll see some text here in green, and the green text is actually sandwiched between these three apostrophe or quotation marks, and that means that this is also a comment. The computer is not going to read that. This will come into a little bit more clarity as we go through this exercise. Again, this is kind of a non-conventional crash course. But one of the things that I want everybody to be able to do is to have something like a starting script to go. And basically how coding works, coding is just a problem-solving tool, right? You still have to set up the problem, figure out how to solve the problem, and then use the code or the computer to do the calculations. So to do this, what we're going to do is we're going to go ahead and start a new script. And what I want everybody to do is add this line of code. And it says if underscore underscore name in all lowercase underscore underscore space 2 equal signs space quote underscore underscore main underscore underscore end quote and then a colon. And what you'll notice is this turns purple, this turns green, and this is just a very specific thing to Python. So again, if you just type this into Google, you'll understand. You can go down the rabbit hole of what it means. But essentially, having this line in this what's called the script over here is going to allow us to define functions, which is kind of how you do things traditionally in Excel, and then it's going to execute everything down in here. So what you'll see is we'll define functions up here. So we'll say, okay, well, we're going to give this an X, and it's going to output a Y. The computer is going to run that code on line 6 and 7, and then when it gets down into this quotations in here, it's going to actually run it, and it's going to know to call that function because that function exists. So again, don't worry too much about that, but what I want you to know is Python is this really interesting language and everything goes on tabs. So everything after this comment, you'll have to see this is a comment. The computer is not going to run it, but you'll notice that it's indented. So one of the most common errors you'll get in Python is an indentation error. And so everything that is on this indentation is going to be read by the computer. If you tab over here, this will give you an error. And if you tab over this way, this will also give you an error. I just want you to know that. It will be pretty self-explanatory as we start to code because it's intuitive to kind of, as you go into these statements, as you'll see later on in the semester, to keep your code kind of moving in. It helps your eye follow the flow of the code. So anyway, that's what everybody needs to type into their command, and if you go ahead and hit the little green arrow, nothing should happen. Actually, you should get a little error because there's nothing in this command in here. If you know, that's fine. There's one other setting that I need everybody to do in their Spider, and that's to pull out these plots to make them interactive. And again, you might be running a slightly different version, so your buttons up here will look a little different. But what you need to do is essentially get to the Preferences menu. So you can click this little wrench. On a Mac, you can go to Python Preferences. I think on a Windows, it might be under Tools or one of these things up here, and you'll see Preferences. And it'll have a wrench. You go ahead and click that wrench. And what you need to do is you need to go down to this IPython console, and under the graphics tab, mine has already been changed, but yours probably defaults to this inline mode right here, and that means your plots are only going to pop up over here, and they're not going to be interactive. So you have to click this download and change it to automatic. Go ahead and hit apply, and then your Spider is all set up, ready to go. So what we're going to do is we're going to do, like I said, a crash course. So we're going to have an assignment that I'm going to give you. You can essentially work through this with the video, and then you can save your Excel plots, and you're going to just put your plots in this code, bring this to class with you on Monday, and this is what's going to be graded. But I'm working under the assumption here that everybody has at least opened Excel or Google Sheets and kind of has an understanding of how to use Excel to do basic calculations. And so what I'm going to do is I'm going to go through this exercise. I'm going to show you how to do it in Excel, which everyone should be kind of pretty familiar with, and I'm going to show you the equivalent in Python. Now again, this is kind of the non-traditional way. We're not going through data types. We're not going through a lot of that syntax, but I want you to take away this like little script that allows you to plot things. So what we're going to do is I'm going to just go ahead and open a blank Excel here, and I'm going to go ahead and move this to my left-hand side of my screen, and I'm going to zoom this in so that you guys can hopefully read this in the video. All right, now the first problem is what we want to do is we want to create a plot of sine x and cosine x in Excel and Python. We want to do this from a range of 0 to 2 pi in increments of pi divided by 15. I think I meant 16. Let's make it 16. And then what we're going to do is we're going to make the sine curve black, the cosine blue. We're going to make a grid, and we're going to make sure that you have axes labels on both plots. Okay, so what we're going to do is first we'll do this in Excel first, right? So first, like in Excel, what we might want to do is we might want to call this variable name x, and we're going to have a column of x's. And this is the part of the problem when you're working through any kind of programming solve problem or even any math problem in general. You want to really identify what do you know, so what's your independent variable and what's your dependent variable. What do you know and what do you want to solve? And so in this case, we are going to define x. It's going to go from 0 to 2 pi in increments of pi divided by 16. And we're going to calculate y. And let's just call this sine y as a variable and cosine y as another variable. So the first thing we want to do is in Excel we're going to put 0 because this is going to be our first number. And then what we're going to do is we're going to want to add pi divided by 16 to this one. So in Excel, if you do equals pi quos, it knows that that's 3.14159.265, right? So what we need to know first is I'm going to just put in here, we're going to go equals to 2 times pi, and I believe it's going to be 6.28 or something like that. So what we're going to do here is we're going to go equal sign, we're going to take our previous value, and we're going to add pi divided by 16 to it. And you'll see it's now 0.19, and of course in Excel we don't necessarily need to see all the digits, so we can kind of break this down to 2 decimal places in it. Ultimately we want to get to 6.28. So in Excel what you can do is you can either Command C or Control C, right click copy, and then you can paste the formula there, and Excel is smart enough to know to add the previous cell to the next one, right? And again we can copy this again and we can paste this, and it's kind of tedious. You can click this and then there's a little box in the lower right hand corner, and this is actually just copying that formula all the way down. And again we want to get to 6.28, so we're going to just keep dragging this down. Right there is 2 pi. And so again, if you double click into the cell, you can see that it's taking this value and it's adding pi divided by 16. So in Excel, this is pretty straightforward, and it's pretty visual, right? So we have this x value. We've now defined it from 0 to 2 pi. Looks like there's 34, well, 2 to 30, there's 33 values there. So the equivalent in Python is pretty easy. So again, without going into details, one of the powers of Python is the fact that you have this access to these amazing libraries, these open source libraries that people provide. But we're going to depend on 2 of these very most popular libraries that come default with your download of Anaconda. So what I need everybody to do is at the top of your script, you're going to write import numpy as np. And so this is actually telling the computer to import this package called numpy, or numerical Python. So numpy is short for that. And again, if you want to go down this rabbit hole, if you Google this, all kinds of documentation will come up, and you're going to come in and you're going to import it essentially shorthand as np. So in Python, anytime you do np dot something, that allows you to access this library. So again, we're shortcutting this. You don't necessarily need to know the details right now, but you can Google that, and it'll just bring all kinds of documentation up. The other thing that we're going to have to import to do plotting is import matplotlib.pyplot as plt. Now again, for those of you that have never done programming before, everything is very case sensitive. So again, you're going to type import, that will turn purple, and you're going to do matplotlib.pyplot as plt. And again, what you're doing here is this is a default library. If you put in matplotlib into Google, you will see example after example. I think this is probably the package that made Python really grow among the scientific community. And what you're doing is you're just telling it to bring in this package as PLT. So you now should have 3 lines in your script. And what we're going to do now is we're going to do exactly what we did over in Excel here, and we're going to create this list of numbers. And you'll see we had to do it over here by adding the previous one, dragging it down, and it was a little bit tedious. So what we're going to do here is in our init main, because we want it to run, we're going to type x, which is this point over here. This is our variable name or our column header, equal. And what we're going to do is we're going to type np dot. And there's usually 2 ways to do this. There's linspace, which will tell us, you'll give it the start, the end, and how many places you want. Or there's something called a range, where you can give it the start value, the end value, and the increment. And I believe that is what we want. So we're going to start typing a range, and if you hit tab, Python, this nice interface that you've just downloaded, actually knows that this function exists. And so you can click it, and it will bring this up. Now there's a weird bug. If you come over here and you type it in this, np.arrange, it will tell you need your start value, your stop value, and your step. Okay, so again, what we want to do is we want to start it at 0, we want to end it at 2 times np.pi, and we want to go in increments of np.pi divided by 16. Now, this np.pi, that's the equivalent of me in Excel going pi like this in Excel, but if we do np.pi, numpy knows what that value is. So this is equivalent to kind of doing that thing. And now if you hit this little run up here, you'll see that you actually get a variable over here. Yours probably defaulted to whatever this help was. If you go to Variable Explorer, you can now see that you have a variable x, and if you double click this, you'll see 0, 0.19, 0.39, and I guess if we were to exaggerate these out again, a couple of places in Excel, you would see that we have the same values, 935, 0.39, so on and so forth, and we ended up at 6.08, so we ended up 1 short. So with the arrange function, you actually have to go 1 further than you need to. So plus np.pi divided by 16. So this is telling us to go 1 further, and this has to do again with details that you're not really all that concerned about, starting with indexing at 0. But for example, now when we double click our x, we go to 6.28319. So again, what we did in Excel was copy paste can be replaced with essentially 1 line of code in Python. So the things that I have up on my screen right now are actually 2 equivalent things. We're going from 0 to 2 pi in increments of pi divided by 16. And what we're going to do now is we're going to do some calculations. Okay, so let's go back to this Excel example. So what we want to do is we want to calculate the sine of Excel. So again, in Excel, it has a bunch of built-in functions. It has a bunch of things. Like Excel knows what the absolute value is and knows what sine is. But to access those, you have to start with an equal sign. And so when you put an equal sign, Excel knows to start a function. And what we're going to do is we're going to type sine. And again, you can see these most recently used functions, they pop up. And then we're going to put a bracket, and we want to calculate sine of x, right? And again, all this did is it takes sine of x, and this is right, because this is the y component along the unit circle, and it should be 0. And when we get to essentially pi over 2, we should see a value of 1. But you can, again, in Excel, you can take this formula, you can copy it, you can paste it, and if you double click it, it's smart enough to know that this is your input variable, and this is your output variable. So we can paste it again, we can paste it again, or we can grab this little corner and we can drag it all the way down and we can paste it. So right here, this obviously is probably pi over 2 based on our sign. And again, if we do equals to pi divided by 2, 1.5707963 as pi over 2. So this is passing our gut check. So again, now we have an x value, a y value for sine. So how do we do this over here in Python? So Python, it's going to be, again, a one-liner. So we're going to call our variables sine y. So if we assign this value sine capital Y equal, now again, just like in Excel where I had to put the equal sign for it to look up what function we need to use, we're going to use the package called NumPy. If you actually just download Python, Python doesn't have a sine function, but NumPy, when you import it, it does. So you're going to start with np.sine, and we're going to close our brackets, and we're going to just put x in there. And the way that this works is it knows to take the sine of every one of those values of x. So if you go ahead and hit the little green arrow up top and run this, what you'll see is now you have x and you have sine y. And again, if we were to expand these things out in Excel so that we have, whoops, a couple of decimals, you'll see 0.19509, 0.38286, right? And then 1 is out column 8. These are the same values, right? And what you'll notice is when you click this editor, it actually colors them by value. So here blue is red, and you can actually start to see the sinusoidal color coming out in these values now. But nonetheless, these things that I have on my screen here are equivalent, right? So we've just taken a variable, we've done a calculation based on every value of x. So cosine is going to be the same thing. In Excel, we're going to go ahead and equal cosine of our x value. And again, we can right-click copy. Whoops, we can right-click copy this. We can then paste it. We can paste it again. Or we can just take this little drag down and drag it this way. And again, at x equals 0, we're at 1, and we should be at 0, or in this case, e to the minus 17th for pi over 2. So again, in Python equivalent, we're going to call this variable cosine with a capital Y, cosine capital Y, and we're going to equal to np, and guess what? NumPy has a cosine function, and we're going to just call it x. And again, if you now hit run, you'll see you have cosine y, a variable name, cosine sine y, and then x. And again, if you click this, you'll see we have 1, 9.807, -1, and then here actually it's even this, they're probably using the same algorithm because here I have e to the minus 17th and e to the minus 17th. So again, just what I want you to be in mind is don't be afraid of programming in general. It is really the same thing. It's just kind of a format change of how you have to wrap your brain around things. So in this case, x is just a column of numbers. Sine y is now a column or a list of numbers, and same with cosine. Okay, so the next thing that we have to do, and what you'll do throughout this class, is to create plots. Okay, so again, in how you've probably done this previously in classes is you've probably used Excel. So I'm going to make my Excel window a little bit bigger here. And what you do is you click a box, then you go to insert, and you usually insert one of these scatter plots. And again, do you want it just as dots? Do you want it as dots? Let's just do just lines now, right? And I'll show you in Python you have control to do all of these plots too, all within the same line of command. So when you click this, right, you usually get this blank box. And then what you have to do is you have to select your data, right? So we're going to right click, and we are going to then select our data. And what we're going to do is we're going to add a series, and we'll call this sine capital Y, and we're going to select our x values, right? It's kind of tedious. And again, if you have more than 30 values here, you have to scroll all the way to the bottom, right? If you have thousands of lines, it can get kind of tedious. But again, you've assigned this column as your x, this column as your y, and when you hit OK, you can actually see here's your sine curve, right? And again, to label axes in Python, again, for the assignment, we want this curve to be black. So what we're going to do is we're going to right click, and we're going to do format data series, and we have to go to this fill line, and we have to do the line, and we want it to be black, and maybe we want it to be a little thicker, right? And then all of these weird decimal places, you might want to round that, and I can't even remember how to do that in Excel. You've got to right-click format numbers, text options maybe, no, axis options. I don't even remember in Excel how to do this. Format axis. Display units. Labels. Number. Oh, here we go. We only want to round this to 1 decimal place. And when we do that, and then the same with this one, 1 decimal place. Okay, and then again, to add axes labels, you have to go up here and you have to add a chart element, and you have to add axis titles, primary horizontal, axis titles, primary vertical, and again, so we'll do amplitude, and we'll do x values or something, x values, something like that, okay? And so now you have your plot in Excel. And again, this is just x, y, and we've changed it to black. So how do we do this in Python? Well, again, you have to have this important line up here called import matplotlib.pyplot as plt. And again, without going into details, since this is a crash course, you can Google this and you can come up with a lot of things. But essentially, we have to build this from scratch. So I'm going to show you how to do this in a way that you can adjust these scripts throughout the course to plot whatever you want. So the first thing that we need to do is we actually need to create a figure. So what I call this figure 1, and what you're going to do is plt.figure, and what you can do in here is you can call it my first figure, okay, in the name of hello world. And if you go ahead and hit run, what you'll see is when you run, you'll actually get a window popped up, and it's titled my first figure. Now again, if you did not go to settings, it might just show up over here and it's not going to be interactive, and so on and so forth. But in the meantime, if you've done it right, you have this. Now you can close this window out. And so what we've done is we've created a figure to start plotting on. So the next thing that we need to do is we need to add a set of axes. And to do this, what we're going to do is we're going to call this axes. So this variable name is an axes. And we're going to take figure 1. And again, Python is what is called an object-oriented language. So figure 1 is a variable, but it's a variable that has all of the properties of figure. So if you type figure 1 dot and then add subplot, and what you want to do is you want to do 1, 1, 1. And what this allows you to do is, you know, when you guys have read papers or looked at things and you have subplot 1, 2, 3, 4 all in the one figure, this is telling you that there's one row in this figure, there's one column, and then you're actually working into the figure 1. So for right now, I would just leave that as 1, 1, 1. But again, if you want more information, if you just to matplotlib.pyplot, add subplot, you will find documentation galore. Again, I'm just kind of showing you how to set this up. So now if you run this again, what you'll see is you have your my first figure, and now you actually have a set of axes on this figure. And so what we're going to do is we're going to populate our axes with specific x values, y values, and we're going to change this plot. So all we're going to do now to do exactly what we did in Excel is we're going to do ax.plot. So again, ax is a variable, but it's actually an object, and it has this attribute called plot. We want our x values to be x, and we want our sine y values to be y. And when we go ahead and run this, what you'll see is there's your sine values, right? And again, we go from -1 to 1. Excel chose some default values, Python chose some default values, so on and so forth. But the next thing we want to do is maybe make this line black and a little bit thicker. So again, if you were to go to the documentation and you do matplotlib plot, what you'll find is pyplot.plot. Here it is. There's all kinds of documentation, and it'll tell you essentially how to change figures. You can change symbols, you can add colors. So again, black here is abbreviated as K, Again, I'm not going to go into detail here, but feel free to kind of explore. I'm just going to show you the very basics on how to push the buttons. So in this plot, it's going to be an option. We're going to do comma, line width, all lowercase, and we're going to make it 2. And so that's going to make our line a little bit thicker. So here's when we hit run again, you'll see now it's a little bit thicker. Like we can go to the extreme here and make this 10, and you'll see that that line gets really thick. Okay, so right now we'll leave it at 2. And what we're going to do is we're going to set the color, which is C, and we're going to set it to black, which is abbreviated as K. And what you'll see now is you've got a black line that's roughly 2. All right, and now to label the axes, it should be pretty straightforward. I'm going to try and think of the okay. So to label the x-axis, what you're going to do is you're going to hit a new line, and you're going to do ax.set x label, and then in quotes, single quotes, you're going to just put in, what did we call it in Excel? X values. So x capital values. And again, same thing in y, ax.set, instead of x label, it's going to be y label, and it's going to be amplitude, something like that. And again, you'll see in Excel we have the grid on, so what we're going to do is axis.grid and leave that on. And what we'll see now is we will see a plot very similar to the Excel one, something like that. Now again, you can resize this, you can change the vertical exaggeration, which is something we can get into later, but for now you can just leave the default. And again, you can see your plot. So again, there is your sine curve with your x-angles. And so to save this figure and put it in there, if you go ahead and hit save, you can actually save this as a PNG. We'll just save it on my desktop for now, and we'll call it my first figure. And then you can go to desktop, and it's there, my first figure. There it is. And that will actually just be able to be dropped right in to your Word document. Right? There's your Python plot. So in the meantime, let's just finish up this first problem, which is we want to also plot cosine on top of this, because again, throughout the course, you're going to want to be able to plot multiple things. So in Excel, what you would do is you would right-click, select data, we would add another series, and we would call this cosine y, and we're going to have to select all of our x values, and we're going to then have to select all of our y values for cosine. And again, this is the most basic example. We should see a 90-degree phase shift. And in this case, we want it to be blue, so we'll go ahead and make it blue, and I think we'll make the line a little bit thicker is what I did last time. And so again, you now have amplitude, x values, y values, and here's their thing. So again, if you were to right-click this, and you can go to, is it copy chart maybe? Copy, and then in your Word document, for the homework or for the lab assignment that you're bringing in the lab on Monday, you can go ahead and, where did it go? I minimized it. You can delete this, and you can right-click paste special as a PNG, and there's your x values with it labeled. Okay, so there's that one. And then what we're going to do is we're going to see the same kind of idea here in Python. Now again, pretty straightforward. If you just take this guy, this axis, we want to add it to the same axis. So it's going to be ax.plot x cosine y, line width equal to 2. And instead of being black, we're going to make this one blue, which is single quote blue. And again, if you go back to the documentation, all of the colors are marked here. So blue is B, G is green, red, cyan, magenta, yellow, K, white, so on and so forth. And then when you go ahead and hit run, you'll actually see that your script pops up. Oh, whoops, we got to close the script out first. And there it is. So again, we'll save this as a PNG. We're going to replace it, and we'll go back to this Word document, and you will see that you have completed this first problem that you want to bring to class. So just key takeaways from this I want you guys to think about is that, again, the whole idea behind Python programming, again, without going into the details of what a string is, what a list is, what all of the traditional approaches is, we're going to be using Python to essentially do mathematical calculations and visualize them, much like we can do in Excel. Now, and what we can do is, again, in Excel, we have these default functions, in this case, sine and cosine. We assign them to a value, we calculate them, and then we plot them up, and then we save them. So that's going to be lesson number 1. So in lab on Monday, what we're going to do is we're going to go through an exercise where we actually create a more complex function. We're going to create our own function instead of sine and cosine, using our own. We're going to put something up here, and we're going to essentially do just this. We're going to create a function, we're going to calculate a value, and then we're going to plot it up. So I hope to see you in lab on Monday. We're going to go ahead and work through some problems there. All right, thanks. Bye.